Hi there, I'm Mrs McTaggart and this is lesson 2 in the similar shapes topic. You should have already watched video 1, which was looking at very basic similar shapes and talking about scale factor. In this one we're going to look at and specifically similar shapes involving triangles and parallel lines. Now we know in maths parallel lines are important, and if they're shown in a diagram they mean something. So what happens is what's happened is this outer triangle is an exact enlargement of the small one. If you think about how I've maybe drawn this triangle, is I've drawn the little one and when I've stretched down the cursor, it's made it bigger. So it's an exact enlargement of the one above. And the reason it's an exact enlargement is because, well, they both share this common angle up the top here. And even if I cut a line across here, albeit a bit straighter, that would be a similar triangle as well. Or if I extended it out again and kept going, albeit with straight lines, they would be similar. So because they're sharing this common angle at the top, they are mathematically similar triangles. Now my top tip for any of these examples is to first of all draw the two of the triangles out separately. Now this is not going to be wonderfully drawn, so forgive me. So I'm going to draw out the small one again and mark on that this is 6 and this is x. And I'm going to draw out the bigger one and I'm going to mark out that this is 10. And then that combined length is 9 plus 6, which is 15. So I can almost effectively ignore the green bit of the green diagram now and just look at the two smaller ones. Then it becomes exactly like my previous lesson, but it's just presented differently, that's all. So the mission is to find out what x is. Now I have a reduction. I'm actually going from the bigger one to the smaller one. So I've got a reduction scale factor here, and it would be the small over the big number of the corresponding sides. So my reduction scale factor would be 6 over 15, which simplifies down using the 3 times table to 2 over 5. So x would be 2/5 times the length of 10. And then you would just do divide by the bottom times by the top. 10 divided by 5 is 2. 2 times 2 is 4. So the missing side is 4 centimetres. Now, as far as possible, I do all my examples without a calculator. You could easily go and simply do 2 divided by 5, which becomes 0.4, and then do 0.4 times 10 if this was on a calculator paper, okay? But I like to prepare pupils for when it's not a calculator one. Here is a similar one. Again, I call this like the egg timer question. It always reminds me of an egg timer, the way these shapes are. So, like, there's no parallel lines on this one, but like if you think of your ironing board, unless you've got a wonky ironing board, the table bit is always parallel to the ground. So I've drawn in the parallel lines on my triangles here. Now, these are mathematically similar again because we know in maths that opposite angles are equal. So what I need to do is I need to almost like flip that big triangle around the way. So I'm just going to flip it around. So here's the common angle at the top. Now, this is what I'm after here. This is the length. But you have to be very careful where you're going to put the 75. Imagine this being spun round. It's going to be rotated. So the 75 is on the left just now, but when you rotate it, it will go to the right-hand side. And then that's brilliant because then that corresponds with the 40. But if in doubt, I always tell pupils, turn your page. And this is a specific question that I always say, this is why you have to draw them out separately. So now I've got my two triangles. I've got my small and the big one. I am looking for the missing length in the bigger triangle. So this is an enlargement this time. So my enlargement scale factor, I'm going to do ESF for short, would be big over small. So it will be 75 over 40. So I'm going to do 75 over 40. Now if I want to simplify that right down using the 5 times table, that would be 15 over 8. So my missing length will be my scale factor of 15 over 8 times 48. Now again, if this was with a calculator, you could go simply and type 15 divided by 8 and turn it into a decimal. The numbers do work without a calculator though, because 48 and 8 do work. So 48 divided by 8 is 6, which leaves me 6 times 15. I'm just going to write it out to let you see. And 6 times 15 would be 90. So the missing length, the length of my ironing board is 90 centimetres. So watch out for these ones, okay? The biggest tip is the minute you draw out small and big, you've got rid of the difficult part of the question. Then I'm going to show you two much more challenging ones. The placement of the unknown side thereafter in the question makes this a wee bit more difficult. So again, these are mathematically similar because both these triangles have a common angle here using corresponding angles. We've got a big old F shape going on. They also share this corresponding angle up the top there. So I'm going to draw out small and big. So my small one is the 13 and the 12. And my larger one would be 15 along the bottom. And just be careful, X is not the full length. X is like this little bit to here, right? So we've got two options. We could call this 13 plus X and go about using algebra. Or we could call this bit a different letter altogether and call it Y. And then when we're done, take away. So what I'm going to do is I'm going to do this method. I'm going to do two similar questions with a different method for each, just to show you how it works. So we're going to just forget the 13 plus X is down. I'm just going to call that missing side Y. So this is an enlargement. So my enlargement scale factor will be the big over small, so 15 over 12, which using the 3 times table simplifies down to 5 over 4. So Y would be my scale factor 5 over 4 times 13. Now I'm going to have to go to my calculator for this one and do 5 divided by 4 and times by 13. Which of course I'm just going to turn it to decimal just now because I always work in fractions so that I can do it on calculator. But that is just 1.25. Multiply it by 13 on your calculator makes that Y length 16.25. Now if the great big length is 16.25, I want to know what X is. So what I've calculated is I have just worked out that this full length from, oops, sorry, I'm not on my pen mode. This full length from here to here is 16.25. So Y is just the difference between 16.25 and 3. So to finish the question, sorry, wrong letter, X equals 16.25 minus 13, which gives me obviously 3.25 centimetres. Okay, that's tricky. So here's another one a bit like it. I am going to do this in a similar way. So I'm going to draw out the two triangles. I'm going to do small and big. So the small one, oh, I don't know what happened to my pen there. My small one would be the one with the X and the 5. And the larger one would be the one with the 7. Now I've got no option this time. This long bit for the full triangle is going to have to be written as X plus 2.6. Okay, now what I'm going to do is I'm just going to move this up so I've got some more room because there's my question now in front of me. Now, I am going to treat this as being a reduction question. I'm going from 7 to 5. So my reduction scale factor will be small over big, so 5 over 7. And then I'm just going to do this question as normal. You'll be a bit freaked out because we don't have a number to multiply this by. But let's pretend. So if I was finding X, I would then do X equals, and it would be my scale factor multiplied by whatever corresponds with X. Well, in this case, it's actually just that. So it's got a wee bit of algebra in it. So I'm going to write this in a bracket because there's two terms. Now, I don't want to be multiplying out by a fraction, so I'm going to get rid of the divide by 7 by doing 7 times X on the left-hand side, which just leaves me with 5 in front of the bracket. And if I multiply that out, I've got 5x plus 5 times 2.6. If you can't do that mentally, you have to do this old-fashioned thing called a sum. 5 times 6 is 30, 5 2s are 10, so that's just 13. And then take away 5x from each side, leaves you 2x is 13. So final answer, if I just squeeze it in here, x equals 6.5 centimetres. Okay, so that's just showing you another really complicated one that came up at the end of a non-calculated paper a few years ago. These are a bit trickier, but it's worth doing them and making sure you can still understand them. Thanks very much for watching. Bye-bye.